So let me do a little bit of writing it down so you can see it better. Okay. When we would normally have RGB, instead we have YCBCR. So this is written this way. There's lots of variations on how you write this. So we usually use this prime symbol after the Y to represent that the RGB was gamma corrected, but we won't worry too much about that. For all intents and purposes, this is the luminosity, and these are the chrominance values. And this luminosity goes between 0 and 255, just like RGB. And the CB and CR are positions on a sort of a square, and they go from -127 to 128. It might be -128 to 127. Okay, so that's for CB and CR. And so what we essentially have is a cube like this, where our Y goes in this direction, and this is black down here, and this is white, and then our CB and CR are in these directions. So this will be CR, and this will be CB. And right in the centre, where both of these values are 0, is grey. And our grayscale line is right down the centre of this cube. And then up this direction, we'll get more and more red, and then less and less red down in this direction. And up in this direction, we'll get more and more blue, and down will go less and less blue.
When you say less and less blue, you mean more yellow? Or?
In this case, yes. Although we call it blueness, actually also in this direction, the less blue it is, in a sense, the more yellow it is. But similarly with red, the less red it is, in general, the more green it is. But these colours only start to look realistic once you put them both back together again, and then combine them with the luminosity component.
So we've seen 3 different colour spaces and sort of roughly how they work. Why would you use one over another?
So in general, if you had a choice, you would use RGB because it's widely supported. It's what ends up needing to be output to a computer monitor, so graphics cards talk in RGB most of the time. If you're going to print anything, you're going to have to produce it into, turn it into CMYK. Most of the print drivers will do this for you. So you don't need to worry about that. If you go into Windows or any other operating system and you print an RGB image, it will convert it to CMYK for you. And that will tell the printer how much ink it needs to use of the different colours. You would generally use YCBCR if you're doing any kind of TV broadcasting. So if you're actually sending a stream of data to someone's television, you need to worry about how much compression you have on that data because it's quite important. And YCBCR lets you do very clever techniques by downsampling the colour components, but not downsampling the luminance component, and people won't really notice. And we'll talk about that when we talk about JPEG. In fact, I should say, it's this fundamental to how JPEG works, is downsampling of the colour components.
We'd like to thank harrys.com for sponsoring this computer file video. They're a subscription shaving service. So if you go to harrys.com, check out some of the products, they'll deliver them right to your door. I've been using Harry's products for a while now. They've recently sent me this chrome razor, which is really, really cool. All the products are really, really nicely packaged. And I've also been using the foaming shave gel and this aftershave lotion. And if you've got skin that's not so good like mine, you'll find these make a really, really nice job of it. So check out harrys.com, the subscriptions shaving service. If you use the coupon code ComputerFile, you'll get $5 off. So thanks once again to Harry's for sponsoring this computer file video.
So JPEG works by